Okay, so the lesson today is on the real number system. We have real numbers and we have imaginary numbers. And all we're dealing with, the imaginary numbers, you do more with in Algebra 2. We'll deal with that a little bit when we get into using the quadratic equation, which if you don't know what that is, it's no big deal. That's halfway through the year. But for right now, we're really just going to deal with the real number system. So within the real number system, we have rational numbers and we have irrational numbers. I'm going to start over here with irrational numbers, and you're just going to add these things into your boxes as we go along. Okay? Feel free. Everybody knows this is on recording. If you watch this on YouTube, everybody just knows that there's a class going on, whichever class it happens to be. If you have a question, you can still raise your hand, and I'll just deal with it on the recording. It's no big deal. This is mainly for kids that are absent, or if you really do need to watch it again, you have access to it again at home. Although I don't know if it'll be posted tonight. I'm not sure yet. Everybody understand? So don't, just because we're recording, this isn't like we can't breathe or ask questions kind of thing. So that goes for the entire time over the year. If you need anything, let me know. All right, so irrational numbers. Irrational numbers would be numbers like pi. Pi would be a good example of an irrational number, okay? Pi, although we like to say is 3.14, it is not exactly 3.14. It is 3.14, yada, 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 yada. It goes on, and so it does not end, which means it does not terminate, and it also does not repeat. If it were to repeat, then it would be considered a rational number, okay? So if it shows a repeating pattern, then it's not irrational. It would be rational. Okay, another type of number that would be irrational would be something like the square root of 17. That comes out to 4 point something. It doesn't repeat. It doesn't end. And so it's irrational. You might also be dealing with something and come up with a number that comes out to like maybe 6.2417, and it just keeps going on and on and on, and you don't see it ending and you don't see it repeating. Therefore, it would be irrational. So let's go over here to our rational numbers. Within our rational numbers, if a number is rational, then it can also be an integer, a whole number, or a natural number. So we're going to start here in our natural numbers. Our natural numbers are those numbers that you would naturally count by. If I were to say, start counting how many students in this classroom there are in this classroom, what number would you start with?
1.
1. You would say 1, 2, 3. So those are natural numbers. 1, 2, 3, 4, and so on. And so write that in that box. The numbers you naturally count by. Then we have our whole numbers. Now, our whole numbers are all of these natural numbers right here, but also includes one other number. Do you know what that might be?
0.
0. The number we don't naturally count by, but it is considered a whole number. Okay, then we go a step further, we have our integers. Now remember, all of these are rational numbers. Rational numbers are these natural numbers, our whole number, now our integers. Now our integers are going to be all the natural numbers, then the whole numbers, which includes 0, and it's going to bring into being another set of numbers. Any idea what those numbers might be? Negative numbers, yes. So we might have -3, -2, -1, 0, 1, 2, 3, and so on. Okay? Those are integers. All integers are not whole numbers. Some integers are whole numbers, right?
Yes.
Let me ask this. Are all whole numbers integers?
No. Yes.
All whole numbers are integers, yes. All of these are integers. Integers even have a little bit more. Okay, but all integers here are not whole numbers because these negative numbers are not whole numbers.
So it's kind of like all chihuahuas are dogs, but not all dogs are chihuahuas.
Yes.
Okay.
I had to process that for a minute. Do you want to say that a little bit louder so that maybe the recording people can hear you?
Okay. So it's kind of like all chihuahuas are dogs, but not all dogs are chihuahuas.
Exactly.
Okay.
That's great. I'll have to add that to my lesson from. Too bad you're the last class that I'm teaching this to because I would surely be using that. All right, and then we have our rational numbers. Now, our rational numbers are going to be all those other numbers that maybe they're not natural numbers, they're not whole numbers, they're not integers, but they're not irrational. Can someone give me an example of a number that we might put in the rational numbers box here? It's not irrational, but we couldn't put it in the integers or the whole number or the natural numbers. Yes, Harley.
Like decimals that do repeat.
Very good. Decimals that do repeat. For example, give me something. 17.4444444. Yes, that would be a rational number. A number like 15.2 would be rational because it ends. It doesn't repeat, but it ends. Bless you. Really important that you understand the root word in rational is ratio, which means that these numbers can be written as a ratio or as a fraction. So, for example, 4/5 would be a rational number. If you want to understand it in decimal terms, 4/5 as a decimal is 0.8, and that decimal ends, right? Okay? All right. You could also have, like, let's say you had 6.138, and it all repeated. If it's repeating or it ends, it's rational. Okay? All right. Now, you have these definitions for natural and whole number, and then you have the rest of them on the back here that goes through the rest of those in case you need to go back and look at those. Okay, and they're in your notes. All right, so now we're going to do a practice together. Okay, and we're going to classify these numbers. It's kind of hard to see up on the board, but you have it right in front of you. So I think the easiest way is going to be I would prefer to look at it each column at a time instead of going horizontally. I'd rather go vertically. Okay, so let's look at let's look at our natural numbers. Our natural numbers are our numbers that we naturally count by, right? Do we naturally count by negative? When we're naturally counting, do we ever say negative square root of 17? No, so we're not going to put an X in that box. Do we ever say negative 2?
No.
Negative 9 over 37?
No.
0.
No.
Negative 6.06.
No.
I mean, who is counting up something and says negative 6.06? I mean, that's not going to happen, right? One reason, because when you're counting, you wouldn't be saying negative amount of something, unless, of course, if you were talking about money maybe being in a hole or something. But all right, what about 4.56 repeating? Is that a natural number?
No.
What about 3.0500500005? No. What about 18?
Yes.
Okay, that's a natural counting number. Any of these other two?
No.
Okay, so we're done with the natural numbers. Let's go to the whole numbers. Now, by the way, if it's a natural number, it's also going to be a whole number, an integer, and a rational number, correct? Okay, but just, anyway. Okay, whole numbers. Number 1, is that a whole number?
No.
What about number 2?
No.
3?
No.
4?
Yes.
So we're going to come over here and we're going to put a little X here. That's a whole number. 5?
No.
6?
No.
7?
No.
8?
Yes.
Yes, this is a whole number. 9 and 10? No. Okay, integers. Is number 1 an integer? Is this an integer?
No.
No. What about 2?
Yes.
Yes, so we're going to put a mark for integer there. What about 3?
No.
4?
Yes.
0 is an integer. Yes. 5?
Yes.
Decimals are not integers.
Oh, wait, what? Oh, that's rational numbers, man.
Correct. That's rational, but it's not an integer.
Thank
Okay,
you.
6. Is that an integer?
No.
7? 8?
Yes.
Yes. 9?
No.
10?
No.
Okay, rational numbers. Is number 1 rational? Now here's the deal. It's either going to be rational or irrational, so we can do both these columns at the same time, right? So is it rational?
No.
No, it's irrational. So put a mark over there. Number 2, rational or irrational? Rational. Number 3, rational. If it can be written as a fraction, a ratio, it's rational. Number 4,
Yes.
rational. Number 5,
Yes.
it's an ending decimal. Good, so it's rational. 6,
Yes.
It's not ending, but it does show that it's repeating, so it's rational. Number 7.
No.
That is not rational. Very good. You can see a pattern about it, but it's not repeating. You can see a 0 continues to be added in there, but it's not repeating. So we're going to say that is irrational. Okay, 18.
Yes.
Rational. Number 9.
Yes. Oh, irrational. Because you can't say 5.
Okay, so
Ratio.
you might think because it looks like a ratio that it would be rational, but we are not allowed to ever have 0 in the denominator. Okay, ever. So, really, there aren't going to be any marks for this one. I'm going to have you write this down. Write undefined, which if you remember doing slope, you had to write that. Undefined, and then write not a number. I'm going to use a little number sign to save me some space there. So we're actually not going to mark anything for that one. And then 10, rational or irrational?
Irrational.
Okay, now, real numbers. Which one of these are real numbers?
All
All of them except for 9.
I think.
All of them except for that weird one, right?
Oh, yeah. And then the little imaginary number, he's not real, is he?
All of them are real except for the unreal
I know.
one. Okay, sense. Okay. Well,
Words by Cade. All of them are real except for the
My dad
unreal
would say
ones.
something like that.
Which is true, right?
Yeah, true.
Oh my goodness. Okay. Okay, now, listen, this is very, very important that you pay attention. So this next little part right here is reminding us how to add and subtract integers. Now, if you look at the board, you can see that on Friday, you're going to participate in a game called Integer War with cards. You're going to have a sub in here that day, and that day is mainly devoted to you working on how to add and subtract and multiply negative and positive numbers. If you're an 8th grader, you should be good. But there are some 7th graders in here who did not get as much as the 8th graders would have gotten when it comes to that. So on Friday, I want you to make sure that all the 7th graders are pairing up with an 8th grader or someone that feels very confident in that so that it's a learning process. It's not about who's fastest and that sort of thing, okay? I need to make sure that when I come back on Monday that you guys feel very comfortable with how to add, subtract, and multiply negatives and positives. Everybody understand? So let's look at this real quick. We've got a few little notes here. Let's look at these examples. This first example says 2 plus 5. Well, that's obviously 7. Okay, look underneath that one. -3 plus -6. 2 plus 5 is 7 because if they have the same sign, you just add and keep that sign. But so 3 and 6, they both have the same sign. They're both negative. So 3 and 6 is 9, and then you keep that negative sign. But what happens if they're different signs? Well, look at the -5 plus 6. They have different signs. So if they have different signs, you find the difference. The difference between 5 and 6 is 1. And then you ask yourself, who is larger, 5 or 6? 6 is larger. 6 is positive, so my answer is going to be positive. Okay? Look at 4 plus -10. They're different signs. So what's the difference between 4 and 10?
6.
Now, who is bigger, 4 or 10?
Negative.
10 is bigger. He's negative, so we're going to put a negative on our answer. Okay, those directions are also right here beside those problems. All right, let's look at some subtraction. Now, with subtraction, what you're going to do first is you are going to add the opposite, or sometimes you have learned to keep, change, change. You keep the first number, you change subtraction to addition, and then you change the sign of the following number. So, -3 minus -5. You're going to keep -3. You're going to change this to plus and then +5. So it's a -3 plus 5. And then you have to go back to your addition rules. So they're different signs now, a negative and a positive. Find the difference. The difference is 2. 5 is bigger, so it's a +2.
Gotcha.
Look underneath. 7 minus -4. change the subtraction to plus, and then the opposite of a negative 4 is a positive 4. So really, that's just 7 plus 4. 11. Negative 3 minus 2. Change the subtraction to addition. And the opposite of 2 is a negative 2. So now we've got a negative 3 plus a negative 2. They're same sign. When they're the same sign, you're going to add and keep the sign. Negative 5. Negative 6 minus negative 10. Subtraction goes to addition. The opposite of negative 10 is a positive 10. So now that's a negative 6 plus 10. A negative 6 and a positive 10, different signs. You find the difference. The difference is 4. 10 is bigger, so it's a positive 4. Now, if you haven't done much with that, that was very overwhelming. Okay? So some of you may have to do some extra practice, or come see me if you need some extra practice. Okay. Now, listen, this is what you're going to do. We're not done, but this is what you're going to do at home for homework. Okay? What I want you to do is I want you to put, here's the numbers, the little number sprinkles.
Right.
You're going to put those numbers where they go on the line. Now, for example, the number 0. What type of number is the number 0?
Whole number.
It's a whole number.
And irrational number.
It's rational.
And an integer.
And an integer. So I would want you to put it in all 3 places. Okay? So you're going to put it everywhere that it applies.
I don't understand the lines.
The lines are just for,
Right.
like, that's just for you to write.
You're thinking
Like, here's all the whole numbers. List all the numbers that are whole numbers. List all the numbers that are integers. List all the numbers that are rational.
Can we put them on the ice cream
Irrational.
part though?
You can.
Because that's confusing.
That's fine. And you don't need to do anything here with the ice cream flavors unless you just want to color it, but you surely don't have to color it. Okay, I'm going to try to stop this.